September 3rd, 1928. While the world cheered for Olympic wins and marveled at the first talking films, a grimy London lab held a secret. When Alexander Fleming returned to his messy lab after a short break, he found one Petri dish that looked off. It wasn't a failed experiment. It was something puzzling, a sign that something big was hidden there. That Petri dish was almost tossed out, but instead of being a failure, it showed a strange sign. A hidden power fighting off germs. In that tiny mold, something unexpected happened. It seemed to push away harmful bacteria while leaving people safe. In a time when even a small cut could be deadly, this secret hinted at a future full of hope. But what was this mysterious force, and how could it change medicine forever? What if I told you that just 80 years ago, a simple paper cut could be your death sentence? In the early 1940s, a shocking 40% of all deaths came from infections we now dismiss with a quick trip to the pharmacy. This wasn't ancient history. This was your grandparents' world. Imagine a young mother in 1935 watching her child develop a slight fever after scraping his knee. Within days, the infection spreads, redness creeping up his leg like wildfire. The family doctor arrives, examines the boy, and then takes the father aside. With eyes downcast and shoulders slumped, he delivers the verdict that crushed countless families. "I'm sorry, there's nothing more we can try." This devastating scene played out in homes everywhere, a grim ritual repeated across continents and social classes. The world of medicine stood helpless as invisible bacterial invaders claimed lives daily. Doctors, trained in the most advanced techniques of their era, could only watch as patients slipped away from infections we now treat with common antibiotics. On the battlefields of World War I, the horror magnified tenfold. Field hospitals overflowed with young men whose modest wounds turned deadly. The antiseptics available created cruel dilemmas for battlefield surgeons: watch infections spread or apply treatments that might kill the patient anyway. More soldiers died from post-injury infections than from their initial wounds. A mere shrapnel cut became a potential death sentence. The same deadly pattern claimed civilians from all walks of life: people with infected teeth, women with childbirth complications, and children with strep throat. For physicians sworn to heal, this reality created a profound psychological burden. Every failed treatment and every lost patient deepened the trauma of medical helplessness. Desperate times bred desperate measures. Medical textbooks from the 1920s recommended mercury compounds and arsenic derivatives, substances now known to be highly toxic. These cures rivaled the infections in deadliness. Patients faced an impossible choice: risk death from infection or risk death from treatment. Physicians navigated an ethical minefield, prescribing therapies they suspected might harm their patients, but having no better alternatives. This medical helplessness created perfect conditions for revolution. The entire world hungered for something effective against bacterial invaders. Medical journals overflowed with failed experiments and desperate theories. Researchers tested everything from plant extracts to chemical compounds, searching for anything that might turn the tide against infections without killing patients in the process. The medical establishment stood at an impasse. Hospitals became places where doctors could diagnose but rarely cure. For the average person, a visit from the doctor often meant receiving a prognosis rather than treatment. The collective trauma of watching preventable deaths created an unprecedented urgency in the medical community. Anyone who could solve this problem would transform medicine overnight and save countless lives. The medical world was desperately seeking a miracle, but no one expected it would come from a moldy mistake. In September 1928, a Scottish bacteriologist returned from vacation to find his laboratory in disarray and his experiments contaminated, a moment of carelessness that would transform medicine forever. Alexander Fleming was not your typical scientific hero. In a lab where chaos reigned, papers piled on every surface, and cultures stacked haphazardly, Fleming's brilliance thrived amid disorder. This creative environment at St. Mary's Hospital in London reflected the man himself. Brilliant but scattered, guided by curiosity rather than methodical precision. On September 3rd, Fleming returned to his cluttered workspace after a family holiday. Sorting through bacterial cultures, his eye caught an anomaly in a Petri dish. A bluish-green mold colony surrounded by a mysterious bacterial dead zone. Where Staphylococcus bacteria should have crowded the plate, nothing grew. "That's funny," he reportedly remarked, perhaps the greatest understatement in medical history. As he studied the strange phenomenon, memories of infected wounds from his wartime service must have surfaced. During World War I, Fleming witnessed countless soldiers survive brutal injuries only to succumb to infections. Now, staring at this bacterial dead zone, he sensed a possibility that made his pulse quicken. This discovery connected to his earlier work with lysozyme, an antibacterial enzyme he had identified in his own nasal mucus in 1922. But this mold, which Fleming identified as Penicillium notatum, produced something far more powerful. Its effect wasn't mild, it was devastating to bacteria. Fleming isolated the mold, grew it in pure culture, and discovered it produced a substance that obliterated many disease-causing bacteria. He named it penicillin. Through meticulous experimentation, he determined that penicillin destroyed Staphylococcus, Streptococcus, the bacteria causing diphtheria, and other pathogens responsible for scarlet fever, pneumonia, meningitis, and gonorrhea. The revolutionary aspect was its selectivity. Penicillin attacked bacteria by preventing cell wall formation while leaving human cells completely unharmed. Previous antiseptics killed bacteria, but damaged human tissue in the process. Fleming published his findings in 1929, but the paper generated little excitement. The medical establishment largely ignored this biological agent, remaining fixated on chemical solutions. His mold juice, as he initially called it, proved frustratingly difficult to work with. Unstable, challenging to isolate, and produced in minuscule amounts. For a decade, penicillin remained a laboratory curiosity. Fleming lacked the biochemical expertise to purify it effectively. He could demonstrate penicillin's power in Petri dishes, but couldn't produce enough to treat serious infections. The gap between discovery and practical application seemed insurmountable. In a cruel irony, this miracle substance capable of saving millions sat relatively neglected while infections continued claiming lives worldwide. Fleming maintained cultures of his precious mold, occasionally demonstrating its properties to visitors, but progress stalled. "I did not invent penicillin," Fleming later reflected. "Nature did that. I only discovered it by accident." What Fleming had stumbled upon was the first true antibiotic, a term not even coined until 1941. In his cluttered laboratory, accidental contamination had revealed a substance that would fundamentally alter humanity's relationship with infectious disease. The numbers tell a staggering story. The little boy with hopeful eyes and the soldier who returned home represents countless lives transformed. Before antibiotics, life expectancy hovered around 47 years. After penicillin's widespread adoption, that number soared beyond 70 years by the 1960s. Each statistic isn't just a number. It represents millions of birthdays celebrated, lives fully lived, and families kept whole. What began in a single Petri dish transformed into humanity's greatest medical triumph. When penicillin first arrived in American hospitals, it cost more than gold by weight. From precious elixirs to life-saving medicine available for mere pennies, this transition marks humanity's leap in medical ingenuity. Today, that small white pill represents perhaps the most fortunate mistake in human history, a dividing line between the world before antibiotics and the one we now take for granted.